day, everyone. All right, so today we're going to be doing part 2 of proofs. All right, let's get started. So we're on page 21, number 4. All right, so the first things we always want to do is our givens and what they feed into, and the last thing we want to do is what we're trying to prove. All right, so first of all, they say BE bisects angle ABD. Now, how did we know that? That was given to us. So boom, right there. Then then they said, so angle, so right here. So now we know angle ABE is congruent. Now congruent means equal. So ABE is congruent to angle EBD. Now what was said just a second ago for that to happen? The magical word that was said was the word bisect. So what they said was that BE bisected this angle right here. They said that this line, BE, bisected all of this. So that means that this cut this angle in half. So what was the key word that was said? The word bisect. So that will be our reason, and that would be angle bisector. So notice I'm trying to figure out what the answer would be before I look at my options, and that usually narrows it down. Okay, then they say that ray BD bisects this other angle. Now, how did we know that? That was given to us. Now, that fed into this next idea. They said that angle EBD, so EBD, so this angle right here, is equal to DBC. Now, we're saying that this angle is equal to this angle. So now this already has a single angle on it because that means one curve. So that means that this other one also has to be one curve. And how did they figure that out? Because they said that BD, this line right here, bisected all of this. So that means that this line right here cut this line in half. And that's what happened. So what was the magical word that was said a second ago for this to happen? And that was the word bisect. So angle bisector. Okay, so now we have angle ABE is congruent to DBC. Okay, so how did you know that? Well, what changed from here to here? So we still had DBC. The thing that was replaced was this right here. So ABE used to be EBD. So where did this come from? Well, that came from up here. So basically, these two are equal, and these two are equal. So we have these things right here. So looking at 2 and 3, basically we're cutting out the middle man of EBD, and we're left with these two. So we're cutting out the middle man, and that would be the either substitution or transitive. Transitive would be the better choice. And hey, look, that's the only choice that we have. Prove is never a reason. So transitive property would be it, where you're cutting out the middle man. So, and that works with what we labeled. Single angle be equal to single angle. So that's perfect. And now let's go ahead and go to the next problem. Sweet. All right, so the next problem. All right, so on this one, I already started labeling this up, but you can just ignore that for a second. Okay, so on this problem, we're on page 21, number 5. We have these angles are congruent, and we're trying to prove that these other angles are congruent. So here we go. We have RSU is congruent to VST. Now, how did we know that? That was given to us. Awesome. Then we have this right here. Now, what changed from this to this? The only thing that changed was the word congruent. It turned into the word equal. So congruent is now the equal sign, and that is the definition of congruence. Congruence means that the equal is the same thing as congruent, and congruent is the same thing as equal. So that's the definition of congruence. It's the only thing that changed. Okay, then from here to here, nothing really like this changed into this, but that it wasn't replaced. Nothing was changed. So this is its own line all by itself. So they're saying that RSU plus USV, and I'll do this in yellow. So this angle plus this angle equals all of this. So we have little yellow plus big yellow equals the whole shebang yellow. Now, how do we know that? That is angle addition. Not just addition, but angle addition. On top of that, we also know, and I'll do this in blue, that VST, that's little blue, plus UST, that's big blue, is equal to UST. So that's all of this. So little blue plus big blue is equal to the whole shebang blue. All right, and that as well is angle addition. Awesome. Now, we just said all these things right here. We have a bunch of those. Now, what changed? So let's look. From line 4 and 5, what changed? So this is still the same. This is still the same. This turned into this. So VST turned into RSU. So that changed because of line 2. VST is the same thing as saying RSU. Now, how do you know that? So because it says in line 2. So what is that? So what did we do? We substituted VST for RSU. So that's substitution. Boom. Not exactly transitive, but substitution is the better choice. Okay, and then we have RSV is equal to UST. So what changed? Well, let's see. This right here disappeared and it turned into RSV because we still have the UST. So all of this disappeared to turn into this. All right, now what's the last time you saw RSV? Well, that was in line 3. Line 3 RSV is the same thing as saying all of this. So all of this disappeared and turned into this. So all of this disappears and it turns into RSV. So that would either be substitution or transitive because basically you're cutting out the middleman. So in this case, substitution's not in here, transitive would be the better choice. So you cut all of this out and you replaced it with what you had in line 3. So all of this disappears to change into this. Okay, so now we're on this line. Now what changed from 6 to 7? Well, the equal sign is now the word congruent. And that would be the congruence, definition congruence. So definition congruence means equal is changed into congruent or vice versa. Congruent is turned into the word equal. Equal is turned into congruent, congruent is turned to equal. So there you go. So that's definition congruent, and that's the answer to 21. So page 21, number 5. All right, let's keep going. All right, so we are now on number 6. So page 21, number 6. Let me just zoom out a little bit here. Get that to fit just so. All right, so here we go. We have angle 1 and 2 are complementary, 3 and 4 are complementary, and we're trying to prove that 1 and 4 are congruent. All right, so 1 and 2 are complementary. That was the first given. Awesome. Then they said 3 and 4 are complementary. Oh, good, that's another given. Fabulous. Now, as of so far, we haven't said anything was equal, so there's nothing really much to mark up right now. All right, let's keep going. Then we know 1 and 2 are 90 degrees. Now, where did we get that from? 1 and 2 are 90 degrees. Well, that came from line 1. So line 1 was saying 1 and 2 are complementary. So that means 1 and 2 are 90 degrees. What was said for that to happen? The word complementary. So that would be definition of complementary angles. Because we said complementary, this happened. So that was the key word. How do we know that 3 and 4 are 90 degrees? What was the key word that happened to 3 and 4? The word complementary. So that's definition of complementary again. Okay, then they said that 2 and 3 are congruent. All right, so let's look up here. Here's 2, here's 3. What kind of angles are those? So they're saying that these are congruent to each other, right? What kind of angles are those? Well, let's look at our choices. Why not use the choices to our advantage? Was it substitution? We didn't substitute anything. We didn't say anything was equal before other than 90 degrees. Is it definition congruence? Or did we change equal to congruent or congruent to equal? No. Or vertical angles? Well, vertical angles say if one on the X, one's above and one's below, that's vertical. Or if we turn our paper, if we turn our paper, look at that. Those are still vertical angles. We just turn our paper. So those horizontal lines would also, horizontal angles would also be the same thing as vertical. So these two angles be equal, or these two angles are equal, and that's where 2 and 3 comes in. So those are actually vertical angles. So let's click on that. All right, so that means 2 and 3 are equal to each other. What magical word was said for that to happen? Congruent or vertical? One of those be okay. Let's see. And we don't have the word vertical, but congruent. So basically, the word congruent turned into equal, and that's the definition of congruence. All right, so we have 2 and 3 are equal, and we marked it on our paper. Then they say 1 and 2 is equal to 3 and 4. Now, how did you know that? Well, that was from up here. That's the last time you talked about 1 and 2 and 3 and 4. So what happened? Well, basically 90 is our middle man. They both equal 90. You just cut out 90, so that means they're both equal to each other. So that would be the transitive, because you're cutting out the middle man. And boop, right there. Okay, then from 7 to 8, what changed? We still have angle 1. And then right here, we have angle 4, angle 3. Angle 2 turned into 3. So a 2 is now a 3. Well, that would be substitution, because you substituted 2 for 3 because you said a second ago that they were equal to each other. So what changed? 2 to 3 is what changed, so that's substitution. Now, what changed from here, from line 8 to line 9? Well, what changed? What changed was angle 3 disappeared on both sides. And what's the best way to get from here to here? We subtracted angle 3 from both sides, so that's subtraction. Oop, almost did substitution. Be careful, they both start with S's. Okay, so that's subtraction. And finally, how did we get from 9 to 10? Well, what changed? They both have angle 1, they both have angle 4. The equal sign disappeared and they changed it to the word congruent. And that's the definition of congruence. And that is the answer to page 21, number 6. All right, let's keep going. So let's go to page 22. Double checking I have the right picture. Yep. All right, so see if I can zoom in a little bit. There we go. All right, so we're on page 22, number 7. Here we go. All right, so we have angle 1 is congruent to angle 4. 4 is equal to angle 5. Sorry, 4 and 5 are linear pair. And we're trying to prove that 1 and 5 are supplementary. All right, so the first thing we always do is our givens. 1 is congruent to angle 4. How do we know that? That was given to us. Then definition congruence. That means an equal sign turns congruent. Congruent turns into equal. So let's see. We were just talking about 1 and 4. So we would still be talking about 1 and 4, and we replaced the congruent with the word equal. So boop, there we go. And as soon as we say things are equal or congruent, we mark up our paper. Hopefully that will help us out later. So 1 and 4 are equal to each other. Now, what was the other given? Well, we said 4 and 5 are linear. So let's see. Yeah, right there. 4 and 5 are linear. Then we say 4 and 5 are supplementary. Now, what was said a second ago for that to happen? So I would hope the word linear would be in here, but that's not. The only other word that was said just a second ago is the word supplementary. So that would be supplement theorem. So basically, the rule for supplement says that if it's a linear pair, it's all automatically supplementary. So that's the only choice. So that says 4 and 5 make a straight line, which they do. All right, next. They said definition is supplementary. Well, what were we just talking about a second ago? 4 and 5. So we're probably still talking about 4 and 5. 4 and 5 add up to 180. Yep, that's the only one that works. So these two angles right here add up to 180 degrees. Awesome. Now substitution. That means we're going to replace something, right? Okay, now we're trying to get to 1 and 5. Right now we have 4 and 5. So what do you think we're going to replace something with? So we're still going to have angle 5. We're going to replace the 4 with the 1 because up here we said 1 was the same thing as 4. So that would be 1 and 5 because that's our goal, is to change this into what we're trying to aim for, right? And how did we do that? what happened from 5 to 6? We substituted 4. 4 turned into angle 1, and that was substitution. And finally, angle 1 and angle 5 are supplementary. How do you know that? Well, let's see. Angle bisector? No, we didn't say anything about bisecting. Supplementary angles? That sounds right. Or angle addition? No, we didn't do angle addition. Angle addition says left plus right equals the whole shebang. That's not what we did. We did supplementary angles. And that is the answer for page 22, number 7. All right, let's keep going. Okay, so now, let's see if I can scroll around a little bit. Here we go. All right, so we are on page 22, number 8. All right, always do our givens first. And then what we're trying to prove is the last thing. All right, so let's see. 1 and 2 are a linear pair. How do we know that? That was given to us. Let's see. We also know we were just talking about 1 and 2, right? So we would still be talking about 1 and 2. Now the question is it 1 and 2 supplementary or 1 and 2 complementary? Well, let's see. Well, it's going to be the supplement theorem, so I'm going to make a wild guess and say supplementary, which is correct. Okay, so we didn't say anything was equal yet, but everything's checking out. So 1 and 2 make a straight line. That looks legit. Okay, what was the other given? 2 and 3 equal 180. So let's write it up. 2 and 3 equal 180. Not 90, but 180. Awesome. Then definition of supplementary angles. So let's see. We were just talking about 2 and 3. Probably has to do about that. Yay, 2 and 3 are supplementary. Awesome. Okay, so we just said 2 and 3 are 180, so that means that 2 and 3 are the words supplementary. Awesome. Okay, now what changed from this line to this line? So we still have angle 3, but instead of angle 2, it's going to be replaced with angle 1. So it's going to be replaced, right? So substitution might be the idea, but that's not on this list, right? So, or transitive, because you're cutting out the middle man, right? So that's not happening. So this would be one of the supplement or complement theorems, which is so congruent supplements. That's what it is. So congruent supplements. So this is another way of cutting out the middleman in specific supplementary terms. All right, so there's that. All right, and yeah, let's just keep going. Okay, so go to the next problem here. And let's see if I can zoom out a little bit, angle it just so. All right, here we go. All right, so we're now on page 22, number 9. All right, you always do our givens first, and the last thing you do is what you're trying to prove. They said AB is perpendicular to BC. How do you know that? That was given. That needs to feed into something, right? So now they're saying the angle ABC. So ABC. So all of this is a right angle. So all that makes 90. Now what was said just a second ago for this to happen? How do I know this is true? Because I said this magical word. What was the magical word that was said for this to happen? And that word was perpendicular. So perpendicular, boom. Okay, then the next part is that ABC is now 90 degrees. So boom right there. So ABC is now is still there. Right angles changed to 90. Now how do you know that? What was the magical word that was said a second ago? And that was right angle. So that's the definition of right angle. That's where that came from. Okay, then they say 1 and 3 is equal to ABC. So 1 and 3 equals ABC. Now that's not a given. Let's see, 1 and 3 equals ABC. Well, that's this plus this equals a whole shebang, right? So that's angle addition. Okay, so then they say 1 and 3 equals 90. Now this is still the same. This is still the same. What was replaced was angle ABC now turns into 90. That was what was replaced. So that would either be substitution or transitive, because they both equal 1 and 3, right? So the middleman gets cut out, kind of thing, right? So that would be transitive, angle addition. Nope, transitive. Transitive is the only one that works because there's no substitution. Substitution probably would have been a better one, but transitive was the only option we had. Okay, next, we just were talking about 1 and 3. So 1 and 3 are complementary, because that's what we were just talking about. So this turns into this next idea. All right, then given. So we reset. So the other given was 2 and 3 are complementary. So right there, 2 and 3 are complementary. That was given to us. Okay, now what changed from here to here? So going from 7 to 8, we still had angle 2. And then, so we have, so this is not enough. So if you can't jump straight from 7 to 8, maybe you need 6, 7, and 8. So let's check this out. We have 1 and 2 are congruent. And look, they both shared angle 3. So basically, you're cutting out the middle man in terms of complementary. That's basically what's happening. You're cutting out the middle man, not in terms of equals, but in terms of complementary, which is what we happened a minute ago. So that would be congruent complements. So on the previous question, we had angle we had angle 1 and 2, angle 2 and 3. See, we cut out angle 2, and we had 1 and 3 in terms of supplementary. So that supplement. So that's what happened. You cut out the middleman in terms of supplementary, and this time around, we cut out the middleman in terms of complementary. So that's what the congruent complements theorem is. All right, awesome. All right, we're getting close to being done here. So 2 more problems. So now we are on page 24. Number 3. So page 24, number 3. See if I can zoom in just a little more. Awesome. Okay, so we're on page 24, number 3. All right, so we always start with our givens first. So 4 and 5 are supplementary. That was given to us. 4 and 5 are 180. Now, what was happened just a second ago for that to happen? What magical word was said? And that was supplementary. Oh, look at that. Definition of supplementary. And then finally, J and K are parallel. All right, how did we know that? Well, we were just talking about 4 and 5. So let's look at our picture. So here's 4, here's 5. So now let's look at our options. Our options are converse of alternate interior, converse of consecutive interior, converse of corresponding. And what that says is if these angles make the relationship of the angles makes the equation happy, then we know we're correct. All right, so look at these angles. What's the relationship between these? So are they on the same side of the transversal or alternate? Well, they're on the same side. So alternate is definitely out. Okay, so they're on the same side. Now, are they in the same position? Let's see. Number 4 is in the bottom left, but number 5 is in the top left. So it's not corresponding. So they would have to be consecutive interior. But we don't know that term, consecutive interior. Well, that's the same thing as saying same side interior. It's just another way. At the bare minimum, you were able to narrow it down. It's not the first one. It's not the last one. It would have to be the middle one. And that's the answer to page 24, number 3. One more problem. All right, let's go to number 8. All right, last problem. Let me move this over just so. All right. Okay, so on this problem right here, we have, we always do our givens first. So 1 and 2 form a linear pair, 1 and 4 are supplementary, and what we're trying to prove are that the lines are parallel. All right, so 1 and 2 are a linear pair. That was given to us. 1 and 2 are supplementary. So what happened from 1 to 2? What changed? Well, linear pair turned into supplementary. So what magical word was said would be linear pair, but that's not one of the options. Well, that would be the supplement theorem. Supplement theorem says if you have a linear pair, it's automatically supplementary. So at the bare minimum, you were able to narrow it down. All right, then we have 1 and 4 supplementary. Well, that doesn't come from any of this. Oh, because it's given. That's awesome. So because it was given to us. All right, awesome. Then they said 2 and 4 are congruent. Okay, so where did that come from? 2 and 4 are congruent. Well, that came from right here. So we cut out the middle man of angle 1, and we're left with angle 2 and 4 in terms of supplementary. So that would be the supplement theorem right there, congruent supplements theorem, because we cut out the middle man in terms of supplementary. All right, so then we're saying that 2 and 4, so that's where we came from. So 2 and 4, so here's 2, here's 4. Now, the train that took us from this train station, here is a transversal, right? So you want to turn your paper until that's vertical to you. So you can turn one way or the other, doesn't matter. So you can go this way or this way, it doesn't matter. Okay, so we turn it this way. We always want to make sure it's completely vertical. Okay, now we have to look at our possible options. So, are they on the same side or alternate? So they're on the same side, so it's definitely not the second one, which is alternate exterior. It's not that. Okay, so are they in the same position? Let's see. 2 is in the bottom right, and 4 is also in the bottom right. So that would be corresponding. So that's corresponding angles converse. And that's it for the day. And hopefully that helped you guys out. Let me put that back right here. So hopefully that helped you guys out, and have a great and wonderful day.